Good morning, Year 4. This is my hints and tips video for our equivalent fractions lesson today. So I've got 4 halves on my board and I want to find equivalent fractions to a half. So I'm going to work systematically and test fractions that I can find that are equivalent. So the first one I'm going to test is thirds. Okay, so we can see that I can't make a equivalent fraction to a half using thirds. Alright, and I'm going to work systematically, and now I'm going to test quarters. So I think most of you know that 2/4 is the same or equivalent to a half. Okay. And now I'm going to test fifths. So can I make a fraction that is equivalent to a half using fifths? And you can see that I can't. And now sixths, which I can. 3/6 is equivalent to a half. And now I'm going to test sevenths. And you can see I can't make a fraction equivalent to a half using sevenths. And now eighths. Which I can. And now ninths. And you can see that I can't make a fraction equivalent to a half using ninths. And now tenths. And I can see that 5/10 are the same as a half. And the last one I'm going to show you is 12ths, because I don't have any 11ths in my bar model resource. So here we go. I'm just having to do it along the top because I don't have any more halves to show you either, but I think you can understand. It doesn't matter whether it's above the half or below the half, we can see it's equivalent. Okay, and here we can see 6/12 are equivalent to a half. So if we line all of the fractions that are equivalent to a half up, see if we can get them all to fit there. We can see, so here is my fraction half, and here are the equivalent fractions we've made, and I'm going to start looking and thinking again about how the denominator and the numerator have changed. And we talked on Friday about whatever has been done to the top, however the top has changed by multiplying or dividing, we must do the same to the bottom. Okay, so here 2 multiplied by 2 is 4. and whatever I've done to the bottom, I need to do to the top. So 1 multiplied by 2 is 2. And there you can see the numerator. Okay, so here you can see that our 2, because basically what we're saying, 2 multiplied by something would give us 6. And there we can see that it must be 3. And whatever has been done there to our denominator must be done to the numerator. And I'm now going to think about 4/8. So here, 1, I write it there, 1 multiplied by something would give us 4. We can see straight away that be multiplied by 4. So whatever I've done to the numerator, I then need to do to the denominator, and 2 times 4 is 8. And here, the numerator has changed to 5. So we've multiplied by 5 here. So I multiplied my numerator by 5 because 1 times 5 is 5. And here we can do 2 times 5 is 10. And my last example that I'm going to show you is here, where I'm multiplying by 6. 1 multiplied by 6 is 6, and here multiplying by 6 would give me 2 multiplied by 6 is 12. Okay, so I'm going to write 2 fractions that are equivalent to 2/3. So because I'm dealing in thirds, I've done a splat box of my 3 times table, my multiples of 3, and I'm going to pick 1/18. Now, what would I have multiplied 3 by? So 3 multiplied by something is 18. Okay, and my splat box tells me that is 6. So I've multiplied the 3 by 6. So whatever I've done to the bottom, I have to do to the top. So I'll multiply that by 6 as well. And 2 multiplied by 6 is 12. So that would be an equivalent fraction for 2/3. So I'm going to do another example as well. So this time I'm going to change, and I could choose any one of these multiples of 3 and it wouldn't matter, I would be able to do it. I'll be able to make an equivalent fraction. So my denominator is going to be in 12ths. So 3 multiplied by something would give me 12, which is 4. So that's what I have done to the 3 to change it into 12ths. And now to make an equivalent fraction, I must do the same to the numerator. Okay, so 2 multiplied by 4 is 8. And here's my favourite fraction, so I thought I would do an example using this one. So I'm going to change my denominator that's in 5ths. Okay, and I can choose any any multiple of 5. Alright, so I'm going to choose, let's go for 15ths. Okay, so what do I multiply 5 by? 5 multiplied by something would give us 15, because however the bottom of the fraction has changed. Okay, and I think most people know that 5 times 3 is 15. So whatever has happened here, we need to do the same to the top. 3 times 3 is 9. Okay, so 9/15 is the same as 3/5. Okay, so just coming onto our sheet, I think you should be absolutely fine through the first 2 questions. Okay, use the bar models, they call them fraction rules, to help you. Alright, but I'm just going to have a quick look at this fraction rule. Okay, so it says label the fractions on the fraction rule. Alright, now if you're not sure about how to do that, okay, you just need to count the number of parts that the length of each bar is divided into. So this one is divided into thirds, because there is 1, 2, 3, and each part would be 1/3. So if we had all of them, we would have 3/3. Okay, and this bar is divided into 1, 2, 3, 4, 5, 6 parts. So we know that each part is worth 1/6. Okay, and then it says use a fraction rule to complete the equivalent fractions. So you can either literally count, if I do that, count, you can see that they're looking at the relationship between the denominator of thirds and sixths. So how many sixths are there in 1/3? And the fraction rule shows you there are 2. And you can also think about the method I showed you before about how the 3 has changed. 3 multiplied by 2 would give you 6, and you can see as well. So whichever one you choose, okay, it doesn't matter as long as you understand what you're doing, and if you can do both, that's super, that's brilliant. Okay, and a very quick look at the last question, number 5. Are the statements always, sometimes, or never true? Circle your answer, draw a diagram to support your answer. Okay, so I've given us a little bit of a heads up for this one. 5a, the greater the numerator, the greater the fraction. Is that always, sometimes, or never true? So I've decided to draw a diagram in fifths, and you can see my bars are divided into 5 equal parts, and the larger the numerator, the more you have. Okay, as the denominator tells you how many parts in a whole, and the numerator tells you how many parts you have. Okay, so you should be able to work that out. And here, fractions equivalent to 1/2 have even numerators. Is that always true, sometimes true, or never true? Okay, and I'm going to leave you to have a look at the diagrams that I drew to prove which one is correct. All right, and the last one you should be able to do without a problem. Okay, work hard, have fun.